Hi there, it's Bill back. We are continuing in week 7 of our Java 2 class. We talked about event-driven programming in one video. We talked about the background of Java Swing in another. We started in writing some Swing code, talked about JFrames and JPanels and their role in making a GUI. We are now talking about buttons. We added buttons in the last video, but we didn't make them go. So we were, of course, in Java Swing. We're talking about buttons. We talked about JFrames, JPanels, now buttons. The thing that we need to know here is that we need to supply a reference to an object that implements the ActionListener interface. So let's look at a couple of different ways that we might be able to do that. Let us first go and let's say that we wanted to do something like we wanted to make the beep work, right? That would be an obvious one. Well, when we see that it needs an action listener, a reference to an action listener implementer, we could go create that implementer down here. So this is one way to do it, not the typical way here, and we're going to see why in a minute. So we could certainly go do something like private class. Now we need to give this a name, which is part of the issue. What are we going to call this? This is an action listener, but it's going to be code that's going to be specific to this particular thing. So what am I going to call this? Maybe beep action listener? Right? And it's a little wordy, but you got the idea. The important thing is that, of course, this has to implement action listener, right? This is an interface. So we're going to have to go write some code, and it's going to first say never heard of an action listener. So of course we're going to have to go get that, and that is going to be up here in import awt.event.actionListener. Right? We got to get this one. This is a little bit of a new one for us, is that it's awt.event. And then the next thing it's going to say is, of course, it's an action listener, but it has to implement something, right? There's a required method for that interface, and it's going to want us to implement something called action performed. Public void action performed. That means when the action that is of interest gets performed with your button, there's not a lot of actions that are interesting, it's the clicking, right? When that is performed, call this code and pass me an event. Now, of course, it won't have heard of action event either, so of course we're going to bring it in here, and I'm just going to go pick out the first part of that so that I can get action event as well. Some of you wonder why I don't put star. A lot of corporate style guides say don't do that. You can get name conflicts. You can just bring in more stuff than you want to bring in. So bring them in one by one so you know exactly what you're getting. Now, this is going to be, again, this is a class that implements the required interface, and the interface requires a particular method, and that method requires or is going to take in an event. That event can be used to decode interesting things about it. So with a button being clicked, there's not a lot of interesting things about that event, but with other kinds of objects, other kinds of controls, widgets, the events might be more interesting and you might need to decode them. Also, if you're using one method for multiple listening, right, for listening to multiple things, then that event becomes more interesting because it will contain, among other things, what thing triggered this, where did this event originate. So that can be interesting. So now we can write our code. So what do we want to do when they press the beep button? Well, I'm just going to let the toolkit do the work because it has a method called, in fact, beep. And beep just rings the system sound. You know, that bling, that when you click something in error, that's the standard sound that the system responds with when it's unhappy with you. So toolkit contains that. We have a toolkit method or toolkit instance data here, right? So you have that here, and it's, notice where it's declared in global class space, so we have access to that here, and we can just do the beep. So now we have written the code which responds to the event, right? Now notice this is one of those cases where we don't trigger the event. The event is going to be triggered and we can respond to it. But what is missing now is the link between the beep button itself and this action listener. We have to tie the two things together because it's that specific button that we're trying to listen to and to implement this particular code for. So somewhere up here, right, somewhere somehow we've got to tell it that we want it to do those two things. So how do we do that? Well, here is one way to do it. We could say beep.add action listener, right? That's the method that says, hey, there's somebody interested in you, and we could simply create a new beep action listener object, and we attach that to the beep button. Okay, so we have the beep button. We tell the beep button, hey, somebody is interested in listening to your events. Somebody wants to know when something happens. Notice you can have more than one object listening to a particular button. So beep, we could have another listener if we wanted, and vice versa. We could have multiple, one listener listening to multiple things on the other end. So that is one way that we could do this. And I will compile, we'll run. Of course, I can't really easily pass the system sound through here, so I might have to make the sound effect myself or put you very close to the speaker with my microphone. So let's see what happens now when we click the beep button, and I'll lean down in case you can hear it. Ready? You probably didn't hear it. It's probably through my speaker in my ears. It went bling. So we hooked up beep correctly. So everything is working there, and that's how we hooked up the code. So this is one way to do it. We know that the button wants, let's go back to the slide, we know that the button wants an action listener implementer, right? So an object from a class that implements action listener, and that interface requires the implementation of the action performed, right? So we had to write that, and then when it's triggered, we can respond by writing code there. So that's one way to do it. But what's going to happen when we go and add one for close? Well, we could copy and paste all of this code and paste it down below and change the name, and instead of beeping, we could make it do something different. So we could certainly do that, right? What you get, though, is a whole bunch of little private classes. Why would we put them somewhere else, right? They're only really for here. You get a whole bunch of private classes that seem like they're more setup than they're worth. Every one of them is going to have the same general setup. The only difference is going to be the name of the thing has to be different if you're going to create different classes, and then this code is going to be different. But otherwise, it feels like the amount of setup versus the amount of actual code that we need is pretty darn small, right? The ratio is too high on the setup for the amount of code. Now, so we certainly could do that. Now, remember I said that you're going to get this event passed to you, and the event could in fact, or would in fact, contain information about what triggered this. Did this come from the beep button? Did it come from the close button? So one thing that we could do here, another option, would be for us to make this simply a button action listener, and then somewhere here we would need to decode what this thing was, because we would want to have an if statement here that says if, and then we would look at the event and see what it has, right? In this case, what was the action command associated with this? How did we get here? So we could have an if statement that depended on the action command, and then we could use that to decode which action we needed to take. So that is another completely reasonable way that we could do this, all right? So in this case, let's make sure we recompile, and then, yeah, everything should be fine here. Well, in this case, I'm showing you an example, so I'm going to put it the way I had it. So that is certainly one way that you can do this. Whether you want to do that and funnel it all there, it means that your eyeballs have to go and look at code that's in this, and it also creates sort of a coupling, right? It creates a coupling between the class code up here that's just in our GUI, and then we have to sort of look down here in this other class and figure out which code goes with which thing based on that. So I don't know, that doesn't feel great either. Now, if you have a bunch of things, think about this. If you were implementing a calculator, let's say, and each button on the calculator is going to have a number 0, 1, 2, 3, probably one listener makes a lot of sense, right? Because every single button that you press pretty much does the same thing, it's just with a different number. So there are times certainly when one action listener that decodes the source and takes action can make very, very good sense. In this case though, it feels still like it's a little bit unnecessary. So there is another way. That way, though, is very strange, right? This is one of the strangest things that you will have seen in Java, right? Very, very odd. So now that we've seen this, though, hopefully it will make a little bit of sense. But this code, like I said, the first time you see it, your jaw drops and you're like, what in the heck is going on here? Okay, so here's how it works. This is called an anonymous inner class. It's anonymous because we're not going to name it. Notice before we had a beep action listener. We had a name of a class. Here we are not going to have the name for a class. So watch what I'm going to do. I'm going to replace that thing, which was the new beep action listener, and watch what I'm going to replace it with. I'm going to make a brand new class that implements action listener. Okay, so all of a sudden this already looks weird, right? Let me move this down so we don't forget, right? So we don't forget where we are in the pattern here. And that thing is going to be defined right here. That thing is going to be defined right here. So I'm going to move that over and notice that that thing is now, look how the brackets go and where this is defined, right? If I move that, maybe I'll move this over here so that you see very clearly where the end of that thing. The end of the statement where I'm adding the action listener is here, but in the middle of the code, in the middle of this, I'm going to write the actual code for the class. And what is that code? Well, I just need to implement the required thing. Right? And I'm going to write that method. Okay? Then this is the end of that. And this is the end of that. This is the end of, right, corresponds to this right here. And this is the end of this thing, which corresponds to that. This is an anonymous inner class. Notice it doesn't even have a name. In fact, it just seems to be lacking a lot of the setup that classes and methods, well, the method's clear, that classes have, right? It just seems to be missing some of the setup here, but it's not. This is exactly how it works. You just say, hey, I am creating a brand new thing that implements an action listener. It doesn't have a name, but you're creating a new one. And when you're creating that new one, the thing that is required in an action listener is the action performed, right? So, of course, I will indeed implement that, and as a consequence, I will beep when that happens. Now, because the action listener is recording the fact that this thing is listening to the beep button, the garbage collector is kept at bay. The reason that this thing is kept in memory is because it's attached to the action listener of the beep button. Does that make sense? So we created an object, we defined this method, so we've actually created the object based on this stuff, and it is kept in memory because it is listening, right? All that is a little bit mind-blowing. I hope you understand. It's a little bit strange. So if we were to remove it as an action listener, because we'll see you can in fact remove them. You can add action listeners. That implies also you can remove them. So if we were to remove it, of course it goes away. It's not a class. There's no other references. It's this little, like, created on the fly little class. This is how you'll see a lot of code done in the internet examples for adding action listeners. When you're creating a one-time thing, right? I don't really care if it has a name. I don't care if it has any kind of reference. I'm not even going to create an object of that type per se, except in passing here. So that is a very common way that that is done. Okay. That might take you a couple times to watch back and walk through how that's created and look at the difference between what I had before and what I have now, and you'll see that it is bizarre, but it does work, and that's exactly how you're going to see this done a lot of times. Now, they won't be so nice and put all the parentheses lined up so nice, right? A lot of times you'll just see close, 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 but if you indent the thing like this, I think you have some chance of seeing what exactly is going on. All right. So, of course, then we could do the same thing with the close button, right? I could say close.add action listener. and do the same thing. I'm going to make a newly created object created from a newly created class, and I'm going to put those things together so it's clear. I'm going to put the close for that here. I'm going to move this over. Then I'm going to again respond to the event that I know I have to respond to. And what am I going to do for this? This is the one time in my class that I ever let students write this code. Generally they write it when they're lazy and they don't want to get out of loops properly. Don't do that. But in this one case, we need to just bring down the whole thing. Right? There's no other graceful way to us to say, oh well, just sort of let the thing go. We could try to call the button, or the thing that happens when they click the X button in the upper right hand corner. That would be more appropriate, but oh well. This is one place where this works, because we really just need to pull everything out of memory. It's sort of a barely graceful crash. So we let this thing just end if they press the close button. So notice we have now added listeners to each of those buttons. Typically buttons need listeners. You don't want a button that doesn't do anything, right? Some other widgets might not need them. For instance, if you have a slider that the user's just moving stuff around, you might not really need to listen to everything that's going on with their movement in a slider. Maybe when they click some button, you can just ask the slider what its value is, and you're just going to use that. So not everything needs an action listener, but buttons usually do. So now let's go test our code. Let's see if everything works with these anonymous inner classes. Let me write it down. Anonymous inner class. Uses an anonymous inner class. Cool stuff. Bizarre stuff, but cool stuff. Okay, so now back to our demo. We'll start the thing up. Here it is. Beep, it beeps accordingly. When I hit close, again, watch, you're watching when I hit this. Do you see the thing on the status bar of BlueJ that says it's initializing the virtual environment? Ready? There it is, and initializing virtual machine done. Cool. So that is very typical of adding action listeners. One of those two ways is what you're going to see, and I gave you some tips about if you want to write one that addresses multiple of these things. If you want one that listens to multiple buttons, for instance, then you could certainly do that. Now, there's some very bizarre things about this. One is this action listener doesn't have to even be in this class. It could be somewhere else. So your mind starts going in very interesting directions. And once we get into some other design patterns, once we talk about the observer design pattern, you will see that this is exactly what's going on here, and that will make even more sense. So it all circles together and is in lovely consistency, which we certainly appreciate. So that brings us to the end of our lesson on buttons, but also on anonymous inner classes and writing action listeners and all of that good stuff. That's all here. If you want to know more about that, look this stuff up on the internet. There's one tutorial at the bottom that's listed here, and I talk here about the fact that sometimes you create a bunch of tiny ones. That doesn't seem right to do one thing. So your option is you can make an anonymous inner class, or you can do the other thing using the event to decode which thing it came from, which object triggered this thing, so that you can pay attention to what you need to do. Now, what I'm not going to cover in this video, because I'm just, number one, I'm not the expert. Number two, in terms of text fields, we're going to treat them very simply. But if you wanted to, I'm going to just flash these slides so you can pause and look at them. I do have sample code for those in the class. But so text fields are an interesting one. They have complexity to them because you're actually creating a little document. So you can actually have a mini little document, and you can use a document listener as well as the typical action listener, because the document listener will let you do things like when they're trying to edit, when they're deleting and adding, and you can really respond in great detail to what's going on, but it's like a tiny little document. So it's there. I'll leave it there for you to see. Pause now if you wish. Also, I have just a quick slide on menu systems, and menu systems certainly can be created here. We're not going to use them a lot in classes. You can find plenty of information on the internet, and once you have created that, you can certainly use what we've learned about action listeners to implement ways to execute code based on their users' menu choices. The other thing that I love here that Java provides for us is JColor choosers and file choosers. These are super cool, complex dialogues that you can invoke very easily when the user clicks a button or chooses a menu option, and it goes off and does this wonderful amount of stuff for you. Has a very rich color picker or a very rich file chooser for an open or a save as scenario. So those things are fantastic. Look into those if you'd like. And then the only other thing that I'll just point you to quickly is the fact that you can create GUIs a little more easily. This is a painful way with absolute positioning. There is one tool. This is a very crude tool, but it's one that can work, and that is GUI Genie. And it will generate the code that gets you started in terms of the placement. So it will let you have a series of tools and let you throw controls, widgets onto a dialog, and then it will generate the basic stuff of placing and sizing those tools for you. So it ain't fancy, but it's something if you're just trying to sort of get something to work. But again, there's many fancier toolkits in the world that you can use. We just don't have time to talk about them here. I'll then give you one more quick thing, and that is a list of Swing resources that I have found useful. I have a slide that I'll bring up. Again, pause it if you're interested and see what you can find there. Another reference slide. Again, pause it if you're interested. Lots of interesting things. This is a very big world, and we have touched only the very tip of the iceberg, but hopefully enough to get you started with writing some very simple GUIs and understanding action listeners and event-driven programming. It's a great way to get started and get your mind wrapped around that. Now, we will have another video on drawing on a JPanel, but this one's getting really long, so let's stop here. Thanks for watching these videos. I hope that you're learning a lot and understanding how this new world of event-driven programming, and especially listeners and this whole idea of responding to events is hopefully that's making sense to you as we go. So thanks for watching. Hopefully we'll see you in another video.